the height m corresponds with the height y, and the run 1 corresponds with the run x. So we can write our ratio rise over run of our original slope triangle and rise over run of our new slope triangle. Let's read the next set of directions. Solve the equation that you wrote above for y. So in part D, we're only writing the proportional equation. Part E, we're solving the equation for y. Remember, when we're solving proportional equations, we use cross products. Since I'm solving for y, I'm going to write y on the left. Y equals mx. Seems pretty familiar, doesn't it? What is the general equation that represents any proportional linear relationship? That equation is y equals mx. I can look at any proportional equation and the coefficient of x is my slope of the line, m. Remember, little m represents the mountains and x, y are every single coordinate on the line. Really nice job. Let's continue investigating this on the next page. What about linear relationships that are not proportional? This year we've been really investigating those type of relationships. If a line does not go through the origin, it does not have a constant proportionality. However, it still has a constant rate of change, or slope. Now remember, that's rise over run, or change in y over change in x. And you've learned how to calculate that from a graph with a right triangle and from given 2 points. A translation is another type of transformation that relates a proportional relationship to a non-proportional relationship. Remember, different types of transformation. The last transformation we talked about was a dilation, and a dilation changed the size of the shape but kept the shape the same. A translation is going to keep the size and the shape the same. It's going to just shift or slide that shape around in space. So shifting a line or moving all the points on the line the same distance and direction is a translation. So sometimes a translation is a slide or a glide. For example, if you transform the line y equals 1/2 x upwards by 3 units, every ordered pair that lies on the line moves up 3 units. Algebraically, since we're moving up 3 units, which variable determines the vertical shift? Algebraically, that means you add 3 to every y value since this is a vertical shift. Excellent. So let's investigate our table and our equations that we have here. So we're going to investigate the equation y equals 1/2 x. Notice this is a proportional equation in the form y equals mx. We're going to make a table of values for the equation, and then we're going to graph the equation. So take a moment right now to fill in your table of values and graph the equation. You will pause the video and do this. Okay, so you should have gotten 2, 1, 0, -1 by substituting in the x value and solving for y. 1/2 of 4 is 2, 1/2 of 2 is 1, and so on. Then when I plotted those points, I plotted them x, y using my coordinate plane, and then I'm going to use a ruler or a straight edge to connect my points. Whenever we're graphing a line, we probably want to label it also with the equation. So this is y equals 1/2 x. Let's keep going. The next set of directions say on the same coordinate plane, translate every point 3 units up and draw the new graph, or this will be the image, in a different color. So our original shape or line before our transformation is called our pre-image. What comes before the movies? The previews. What comes before the image? The pre-image. So now we're going to draw the image by translating each point up vertically 3. 1, 2, 3. 1, 2, 3. 1, 2, 3, and 1, 2, and 3. And then of course we want to connect our data points. Now using Using your table of values, add 3 to every y value. So our original y values are going to go right here in the table, and that was 2, 1, 0, -1. Now we need to add 3 to each y value. So we will have 5, 4, 3, and 2. So the ordered pairs will go 4, 2 corresponds with 4, 5. 2, 1 corresponds with 2, 4. 0, 0 corresponds with 0, 3. And -2, -1 corresponds with -2, 2. Comparing those ordered pairs on your new line to those in the table in Part C, what do you notice? Well, 4, 5, that's our blue point. And 4, 2 is right there. 2, 1, and 2, 4. What do we notice? They are the same. They are equivalent. They are equal. So what's the equation of our new line, and how does it compare to y equals 1/2 x? Well, our new line, if you notice, our y-intercept is now 3. Our new equation of the line, we're always going to have our original line, y equals 1/2 x, and then we're always going to add 3. That's going to be our new line. Probably should have written it in blue so it corresponds. Let's write it up on our graph in the same color. Y equals 1/2 x plus 3. Notice both these lines have the same slope, but they have different y-intercepts. They're parallel. How do the lines compare? The slope stays the same. Slope remains 3 and remains 1/2. Y-intercept is now 0, 3 from 0, 0. You could also state that these lines are parallel. Let's do some reading together. The general form of any linear equation is y equals mx plus b. Y equals mx plus b, where m represents the slope or rate of change, and b is your initial value or y-intercept. And you've been using these same vocabulary words for these representations. Now we just have an equation that goes with it. This form is called the slope-intercept form of a linear equation. And that's really important for you to know, is that this equation is called slope-intercept form. You're going to have a lot of problems that ask you to rewrite equations in slope-intercept form. This form is called the slope-intercept form of a linear equation. In the previous example, the equation y equals 1/2 x plus 3 represents a linear relationship with a slope of 1/2 and a y-intercept of 3. And you can see where the 1/2 corresponds with m and the 3 corresponds with b. Excellent. Let's keep on going to our next page. We're going to compare and contrast the two equations using a Venn diagram. Remember, this is what's specific to this graph line equation, and this is what's specific to that one. Because we're comparing the equations, we should just be comparing the equations. So let's see. What are they both? I like to concentrate on what they have in common. They both are linear. They both have y-intercepts. And they both have a slope of 1/2. So what's different? What's different? Y equals 1/2 x. That's the first relationship that we graphed on the previous page. That was the first one that we looked at. Y equals 1/2 x. Well, that one's proportional, which means that the line includes the origin, and the form is y equals mx. Where our new equation is non-proportional, which means the graph does not go through the origin but is still linear, and equation is in the form y equals mx plus b, which is slope-intercept form. We can say that this equation is also in slope-intercept form It's just that the b value is 0, so we don't write it in. Now we're going to use the coordinate plane and instructions to investigate the slope-intercept form y equals mx plus b. This is going to be the same method of what we did on the first 2 pages, except now we're going to look at the non-proportional relationship. So make sure you have your ruler and 2 colors. Use the coordinate plane and instructions below to investigate the slope-intercept form y equals mx plus b. Slope-intercept form. Graph a line on the coordinate plane that goes through the point 0, 4 and has a slope of 1/4. Label the rise and run on your graph with a right triangle. Redraw and label this triangle below. So remember, our first slope we're going to be looking at, m, our slope, which is rise over run, is 1/4. So what we're going to do first is we're going to not draw any numbers on this graph, but we're going to say 4 is above 0 on the y-axis, 0, 4, x, y. Your y-intercept, your x value is always 0. So I'm going to go up to about 4. And then I'm going to draw in my slope of 1/4. Notice the slope of 1/4 is not a slope of 4. It's not extremely steep, but it's not a slope of 0 either. So I'm going to make a slope of about 1/4. And I'm going to draw my right triangle to show my slope. So I'm going to go up and over on my line. How much did I rise? Well, my rise of my line is 1, always going from your y-intercept, and the run of my line is 4. So this slope triangle has a rise of 1 and a run of 4. Excellent. Does this line describe a proportional relationship? No. Does not include the origin. Okay, let's move on to the next question. It asks me to choose any point xy in the graph and draw a right triangle that describes the rise and run. Redraw and label this triangle below the graph. So I'm going to pick, it doesn't matter which point you pick, I'm going to pick a point over here. I'm going to label that x, y. Then I'm going to go directly over to my y-axis and down just to my y-intercept. Notice if you went all the way down to your y-axis, you're not making a right triangle on your line to show the slope. You're just making a weird triangle on your line, which doesn't even include your line. So taking a look at my new green triangle, this xy point corresponds because it has the x value here and the y value here. So from here to here is x, which is the same length as my run. So this is x. My y value, though, remember when we went from the origin up to y, this entire distance was y. But I don't have that entire distance. My distance is actually much smaller than y. What else do we know about some of these heights, these vertical amounts? Oh, I know that this value here, from my origin to my y-intercept, is 4, because they told me my y-intercept was at the point 0, 4. So the only thing I need to figure out for the height of my triangle is what this amount is. If this amount is y, and take away this much is 4, I'm left with this amount. So is it y minus 4 or 4 take away y? You're right, it's going to be y minus 4. So we end up with a positive length since we have a positive distance here. So let's draw our new triangle. And we have a height or a rise of y minus 4 and a run of x. Really nice job. Let's start the next video to continue this problem.